a highly non-technical. There you go. This will be a highly non-technical talk, I guess. So it should be easy to follow. This has been something that Roger and I, and then later on, Roger and I and Dio from George Washington University have been working to put together for a long time. We kind of saw a lot of people doing comparison studies. One of my students did a comparison study with some databases, some of the data. Other people have done different comparisons, and other people have done other sets. And so we kind of had this idea, maybe we should try to gather all the data that we have in one place. This is getting kind of complicated because, as you'll see, we started with about 90 some data sets, and then Roger's been sending me more, and I'm trying to update as we go to keep it consistent. But the idea is, can we get all the data in one place and then look at all the different types of analysis that we do and put that all in one place so that people can kind of do some exploratory data analysis on these things and even combine the analysis over subsets or even all the data. So that's the general idea of the database. As I said, we really started with the second paper. Some of the work that Roger and Abby Colson did, and then Denise Marti from George Washington University and Roger did on the newer data sets, and published our results in the second paper. But really, the first paper by Cook and Cozens was one of the first papers that said, hey, here's a whole list of expert judgment data, and these are the things that we found, and so forth. And so we started with just putting those two data sets together, and then started adding from there. Sorry. So as I said, the general idea is to, if we can just find a way of simply putting all this together. And I wasn't sure that this could be done even practically, and put it together in a nice database. I use Excel. I didn't use Access or anything like that, or real database form, but I use Excel because it's easy. People know how to work with Excel, and so I thought maybe I can keep it in Excel. And I started with a few data sets and a few analysis, and then it grew from there. But the idea was to try to make it so that it was pretty quick to calculate things, and pretty easy to change in and swap out the different data sets. The current file, it's even newer than I have sent to Anka and Tina and Roger. So I had to update a couple things. That was part of the reason I think Roger wanted me to do this talk, is so I'd get off my rear end and finish some of this stuff, which was successful, because the terror of a talk will help you do that. And so I've added a couple things even from what the first data set was. Right now it has 6 tabs. It's about a 1.8 megabyte file, so it's not huge. And it has 6 tabs: front end, which I call, then study data, seed, expert data. A new tab that I added since I sent the file to you guys, called study macro, which is one of the things I really wanted to do. And finally, examples, or it really should be data sets. And what I want to do in this talk is walk everybody through this. And I realized that, usually when you try to do real-time software, it crashes, and Roger's a master at asking questions to crash software. So I first started doing this with screenshots, and then later on, I'll pull in the software and show you a little bit how fast it is and so forth. So if you come into the software, the first thing that you will see is something called front end. And front end is the tab where you can define everything and really pull in the databases that you like. This is the general view of front end. It goes about another 30 or so columns over. I'll show you pieces of those columns and then talk about the things that I'm doing in that. Front end really has this first panel where you can change some things that I thought might be interesting to change, and I'll talk through that in a minute. And then the second piece here in yellow is where we have the indices for all the data sets that we have from the Cook and Cozens paper and the paper with Roger and myself and Denise. One of the things that Roger and I noticed a little bit early on, which I have to fix, is a lot of the earlier files have, all of the earlier files have the later indices. So I'm going to have to swap that around at some point, but I was hesitant to do something that major before the talk, but I will probably finish that this weekend. So let's take the the front end piece and just look at what we can do and why, and I'll talk a little bit about why I did these kinds of things. So if you put your index, I trust you all can see my cursor as I'm circling things. Is that true, Tina?
Yes.
Sorry, yes.
Okay.
Yeah.
Okay. Yeah. Okay. So you can put the indices for the data set in. Once you put the indices, the data set name will appear to the right, as well as the number of experts, the number of variables, the number of log scale variables, and the number of negative seed values. And I'm not using so much anymore, but I had to do that as part of looking at some of the max and mins in my program, and the number of percentiles that the data set uses, 3 or 5. Over on the left-hand side, on the bottom, I have what my maximum values are. Maximum number of experts is 77. The maximum number of seed variables currently is 48. There is one study with 48 seed variables, and I have that in here. And the maximum seed times experts is about 799 rows. So I can expand upon that, but right now those are the maximums. In case we add something that blows this, I'll need to know to expand on that. Then I have some of the 4 things that you can adjust in the program. One of the things was, sometimes you might have a seed variable and the overshoot might take the lower bound below 0, and maybe that doesn't make sense for a seed variable. A lot of times we keep that in the program just because the lower bound shouldn't affect too much. But if you're calculating things like means and so forth, which I am going to be doing, I allow for the opportunity to change that bound. If it's a variable that you do not want negative, it'll change that bound. It'll stop it at 0, so it'll truncate that bound at 0. Or you can use the original method, which is just to leave it alone, let it go less than 0. Defining log scale, we've had some discussions on when you should use a log scale or not. So I allow you to enter a power of 10. So right now this says anything larger than 10 to the 4 or less than 10 to the -4, that will be determined log scale. So I'll allow you to adjust that and play with that a little bit. So that's a variable thing in the program. Overshoot value 0.1 is what we usually use, but you can certainly change that. And a 3 to 5 percentile truncation. So there are several data sets that are 5 percentiles. If you want to treat them as 3 percentiles and just drop out the 2 other percentiles, you can put a -1 in and it'll treat it'll ignore the other 2 percentiles and just deal with the 3 percentiles. If you wanted to include the percentiles as they are, you would put a +1 value in there. All the instructions are in these little comment sections that I don't have here, but in the program, the comment will tell you which one to put in. So it allows you to, maybe play with some things in the program and go back and do an analysis and see if that changes things. Roger has done a lot of that in the past for other studies and so forth, but I thought I would include it and keep it as flexible as possible. The rest of front end, as I go to the right, will number right now. When you read it in, all of these things are the way the data sets are entered, which is expert first, then realization 1, 2, 3, 4, 5, 6, then the next expert 1, 2, 3, 4, 5, 6 for the seed variables, and so forth. It's a little easier to reorder them by seed variable. So what I do is I reorder them by seed variable, and then I can calculate a few things for each entry for each expert seed variable value. And then those we of course will use to sum over or average as we want to get the various metrics. So what do I do in this page? So this is a very, very long sheet. I calculate where the item falls for calibration. I calculate the calibration in each score. And by the way, this is automatically adjusted for the 3 percentiles or the 5 percentiles. And there's a particular annoying study that is a 5 percentile, but it uses the 5, 10, 50, 90, and 95 instead of the 5, 25, 50, 75, and 95. So I will also, my program as it reads in, it will adjust for what percentile value you have, and it will calculate the information and so forth based upon the actual percentiles used as you see fit. Other things that I will calculate are the average relative or the relative information for that particular seed for that expert. I also calculate the expected value and the variance of the seed for the expert. So I calculate the whole expert's distribution and use the overshoot from either side, use it as a truncated distribution, and from that I can calculate the for each expert his or her seed distribution, and from that I can get the expected value and the variance of the seed distribution. I then calculate the percentile of the seed. So if I were to take the actual, it should say realization, I think that would probably make more sense. But if I would take the realization and plug it into the expert's distribution, what percentile value would that be? And I'm able to calculate the variance of that. I also calculate the distance of the percentile. If I put the realization in the expert's distribution, find its percentile, how different is that from the 0.5 value? Okay, so I calculate the y distance instead of the x distance. Then I calculate the seed distance in standard deviations and the variance of that, and the seed difference from the 50th percentile normalized by the range of the whole distribution and the variance for that. And the last thing, a new addition, is to calculate the percent error, which is the 50th percentile minus the seed divided by the seed value, or the realization value. This term seed, as I'm presenting it now, is confusing. It really should be by the realization value. So I'll have to go back and make those changes. So really the front end is just a huge calculation page, which I then grab everything else, but I do everything instead of looping or whatever, I do everything in kind of ordered calculations. So when you go to the second page, which is what we call, or the second tab, which is called study data, it gives you a lot of metrics for the study data. So this is what it looks like. That's obviously too small to be anything. So let's pull out each one of the panels so we can talk about it. So the first thing I look at, again, just to make sure you know what you're working with. So I have the study, the number of experts, the number of percentiles, the number of log seeds, and so forth. And it will pull out for the selected study, in this case, EBBP. It'll pull out the min, max, average, and variance of the information scores of the experts, the min, max, and average and variance of the calibration scores for the experts, and the weights, the min, max, and the variance of the weights for the experts. At one time, we were trying to look at correlation effects. So I looked at correlations among some of our metrics as they correlate with the normalized weights. I also looked at calibration and information correlation, which we know is kind of negative. But I also looked at how some of these things like calibration, how does that correlate with the normalized weights? How does the average percentile for the experts correlate with normalized weights, to see if there was anything that would give us a clue as to how good an expert might do.
Why is it NA for the weights?
For the average, because it's always going to be 0.5. I could do it, but it always turns out to be 0.5.
Oh, so you're not averaging over the experts.
I am averaging over the experts, but if all the experts weights sum to 1, so the average would not be very interesting.
No, it would be 1 over the number of experts. I
That's
guess,
right. Yeah, 1 over the number of experts, right? So I didn't put that in there. I could, maybe I should, but I can do that. What's the next thing? So the next thing on this is 3, and I had to trick Excel into printing these. You can use the Excel histogram function. At the time, I didn't use it. This presents a little bit better picture, particularly when there's less experts. So I left this alone. I could replace this with the Excel histogram function, which you would have to then have the later version of Excel to be able to use.
Tom,
But
Tom, sorry to interrupt.
Yeah.
Here.
Yeah.
Is this information score on calibration questions only, or on all questions?
only on calibration questions. The only thing that I am reading in is the calibration questions, those for which we know the realizations.
Okay, that's just as well, because this particular study was uniquely bad. Well,
I have over 100 studies to choose from. So
You picked the worst one.
Well, it was uniquely bad because it concerned the risks of a newly identified virus that was being linked to chronic fatigue syndrome and prostate cancer.
Ah,
And in this particular instance, the experts basically, were giving judgments on risk model factors. And basically, they say we don't know what it is from minus infinity to plus infinity on the target questions. And this was because this was a notorious case of a lab contamination being published in Science as great new breakthrough. And in fact, that was more than 10 years ago, about 15 years ago. It's still rumbling on today in social media that this was a cover-up. Anyway, so this was a particularly bad one if you use the target responses.
Yeah. So I think I should say what we did was we took the set of data for which we had a set of variables for which we had realizations, and then we had to trim sometimes because we wanted to make sure we had a complete set of variables answered for the experts. So sometimes we had to drop out an expert, sometimes we had to drop out a variable to make sure that we had a complete set. And I have all that documented. I haven't put it in the program. I perhaps should, just to let people know what's really going on, because I had to renumber some of the experts from 1 to 7 in this or 1 to n. And in this case, it was to treat this as data, not so much to recapture the project information. So this will these histograms are the histogram of the distribution of the calibration, the distribution of the information, and the distribution of the experts' performance weights. So for that study. One thing that I actually thought of just as a visualization is to do a bubble graph of calibration and information and weight size. And I just put a couple of different ones down, different ones here. So you can see that, there are some where you have a cluster of a lot of weights and then weights tailing off. And there are some where, you don't have very, very many weights that are noticeable. I mean, all these weights are non-zero. Some of them might be times 10 to the minus 5 or whatever, but they're all non-zero because this is not weights that are globally optimal. These are just the performance weights. But it's a nice way of looking how calibration and information affects the weight size and being able to compare that for different studies. So I put a couple of them up here just to give that that feel. The other thing that I started looking at was okay, let's look at if you want to look at particular studies, let's look at the information, the seed percentage, and the standard distance from the mean and the percent distance from the median. Let's see if we can get those distributions or those box plots by first by holding the expert constant and looking at those values over the seed variables. And the second by holding the seed variable constant and look at those values over the variables. So if you can see if there's one seed variable that has been a little bit more influential in maybe spreading some of the experts out or not. Along with, while you're looking at that, I put what are the top experts in terms of their weight. So I put the ranks of the experts in terms of the highest weight, the highest performance weight. So you can kind of look, for example, if you look at expert 6, you see that his or her difference from the median is fairly tight, and he in fact does have the highest weight. Whether that's why or not, who knows? But at least it's something we can get a feel for, start exploring these different points. The next one is where I have some fun stuff, but I think I'll be changing it, and that's the tab by seed. This is what by seed looks like. Again, there's a lot of calculations over to the right. These are the pictures mostly that you can get. When you go by seed, you have to put in the seed for the particular study. It will tell you what the maximum number of seeds in the study is. It'll tell you what the scale of that is. It'll tell you the percentiles and so forth. And then you can go ahead and study that seed under a couple of different things. Range graphs, I think last range graphs I saw Roger, he did them vertically, which seems to make more sense to me now. But these I have horizontal range graphs for all the experts for the seed, where the circles for each plot, the circles indicate the max and min value, the boxes indicate the 5 and 95 percentile, and the diamonds indicate the 50th percentile, and the dashed red line indicates where the realization is. So you can see how the experts did on this one seed variable value. You can see, for example, that expert 10 and expert 6 were pretty close to their median value, was pretty close to the seed value. These next two things are graphs that I was playing with a while ago. They're really pretty useless. And what I think I have to do is change these with the percent coverage. And that's what I'll do is look at how much coverage do I have with 1 standard deviation from the mean, 2 standard deviations, and so forth. It might make a more interesting graph. I was having fun with these because here you can put in a standard deviation value and it'll plot the mean plus or minus that standard deviation value. And the experts' distributions all have different variances and different means. So you can see the size of the bars change a little bit. And then the dotted line is where the realization is. So you can see which one of these are within 1 standard deviation of the realization, or 2 standard deviations if you put 2 in there, and so forth. And then to check the median value, I did the same type of thing, but looking at percentage of the support of the distribution. So if I take 2% or 10% or 5% of the support distribution from the median, will I still be able to catch that realization? These graphs will, as I said, probably change to be percent coverages. One thing that I had fun doing, I'm able to, you can go into the seed and you can put in here either a particular expert value, like I want to see expert 1's distribution, which is kind of the very simple 3-block distribution, which is not terribly interesting. Or I can actually get the distribution now for the combined distribution. I can get the equal weights or the performance weights. I actually now I even can get the item performance weights. Still haven't found a way to get the global weights yet. I'm working on that, but I can get a picture of what that distribution looks like. And basically for the uniscale values, it's just taking all the drop points and linearly interpolating between them. And you can get the percentage values between them and reconstruct the distribution as kind of a histogram looking distribution as I have here. So you can see the different changes in shapes, and the changes in shapes as I put in equal weights as opposed to performance-based weights for both the distribution and the CDF. For the distribution, I will calculate, or have calculated, the mean and the variance. And for the CDF, I've calculated the 5, 50, and 95th percentile for whatever you put in, either this individual expert or the equal weights expert or the performance weight experts. You can see these distributions. Some of the distributions are really, I started, one of the things I try to do is start to put fitting in here, looking at fitting some closed support distributions. And like any real data set, you get excited sometimes. It's like, oh, this is a beta distribution. This is great. And then the next data, it just doesn't fit anything. So you see like really nice forms and then really ugly forms. And so I abandoned that fitting part, but it's still something I would like to get back to at some point. The next thing is by expert. And when you go by experts, all the experts' information, it's the experts' information for calibration information, the weight, all the parameters of interest, all the metrics of interest, like the percent error and the standard deviations from the mean and so forth. I calculate them all, and I calculate their ranks so I can do the rank correlation if I need to. Right now, I calculate the performance weight expert and the equal weight expert. I have to do that with a macro. So this doesn't come automatically. It comes with a macro, which I'll demonstrate if I have time after this. But you get everything so that you can actually get all the expert values, even the performance and equal weight expert. You can also get item weight experts, which I'm working on right now as well.
What is Tagu?
Oh, so that was Tagu. That's a Taguchi measure. I just wanted to see if that had anything interesting. So it's the realization minus the expert's mean squared plus the variance. So it's a Taguchi measure. I had this idea that would be a really good measure, and it wasn't, but I put it in anyway. It's fun, the things that you think are really going to work, and then if you plug them in, it might work for a 3 or 4, and then it goes to hell fast, as you know. So the last thing that I did that I had promised Anka, and Anka has been very patiently pushing me, so kudos to you, Anka, was to put a study macro in. So one of the things I'd like to be able to do is just generate tables of things that I want so we can plot them easily. So I have a page that has on the bottom all the things that you might want, calibration or information or weight values, the correlations. I have to put some of the metrics. I haven't done that yet. And then all of the studies. And if you put an X by the things that you want and hit go, it'll generate for you a macro. So for example, if I say I really just want the calibration and information for these 3 studies or these 5 studies, I think I had a couple more below, and hit go, it'll pretty quickly generate that table for you. And that way we can do plots on things. We can, check subsets of things and how they look compared to other subsets and so forth. And so it's a really nice way of quickly generating. And this is fast because everything in my program, with the exception of performance weight expert and equal weight experts, everything is contained. It's calculated automatically. So this really is just a big copy and paste, and I hope to get a chance to show you how fast it is. Then the last thing is the examples, which really is a poor title for it. It should be called studies. And the studies I have separated. The studies appear as I show you in the second picture here. Expert first, then the seed variable value, and then the 5, 50, and 95th percentile values, or the 5, 50, up 5, 25, 50, 75, and 95th values, and then the realizations. That is the standard layout for all of them. And right now, I think someone asked me, can I just add studies? You should be able to. I have to go back and make sure that my set allows you to add farther on. I think I put my index way over. And the nice thing about this is that I read it into one spot and then deal with it everywhere else. So as long as we can read it into that one spot, we'll be fine. So adding these studies has not been a problem to date. Shouldn't be a problem. The last thing I would like to say is, okay, I still have a few things left to do. I was hoping to get everything done, but I wasn't. I got to add the additional data sets, some more that Roger has sent me. I'd like to add some of the covariates to the data sets, like, was it science related, business related, engineering related? What was the year it was done? Any other type of covariates which might help us sift through this a little bit. I'm going to develop a box plot macro. So I actually gave a talk at MMR a while ago where I was able to generate, I think this is the distribution of expert calibration scores. So all the box plots of expert calibration scores for all the studies. I'd love to be able to generate a chart like this, and it's not hard. I just have to sit down and do it. The toughest thing that I'm working on right now is the optimal performance weights, and that might have to be done kind of manually. So I might just stick those at the end. I might just run all those things and stick them at the end of the current files so that we can call them up. And then add item weights, which is already pretty much done, and then make this available to researchers. The original thought was that I could do this, and then Roger and I and Dial could write 100 papers on this, but I don't have time to write 100 papers, number one. And I think it'd be a useful tool for researchers. And there's certainly a lot of people out there who are looking at these things. And I think any type of information we can glean by doing any type of, exploratory data analysis, anything that will help us, make expert judgment stronger, it's worthwhile. So I really want to get this out there. I'll as soon as it's done, I'll put it on Tina's site, so anybody can have it and download it and play with it. And all I ask is that we keep version control on it. And if you find any errors on it, let me know so I can correct them. I've had students crawl through this So I know that the calibration and information and so forth is pretty correct. But other things, because it's such a complicated spreadsheet now, other things I might have some boo-boo somewhere. I don't think so, but I might. I think I don't have too much time left, Tina, but I'd like to just show a little bit about the speed of these things.
Yes, please.
So let me just drop this down a little bit to 100. There we go. So as I said, the nice thing about this and this this is, goes all the way out here. So this is my big calculation sheet, the front end, but everything is done off of reading in this sheet from the files. And so once I say, well, I want to deal with number 12, which is FCEP. So it pulls it in, and then everything's done. So everything except for the equal weights and performance weight decision maker, everything is automatically done right now at that point in time. And you can go to it, and you can get you can go to the study data and see all the study data information. You can go to the seed. Sorry, I got over here. You can go to the seed variable values, and you can say, well, let me check seed variable 1, do some analysis on that, or 2, and it's all there. So it's all pops up really pretty quickly. The only thing, as I said, that is not really fast right now, and I have to do this, I put this at the bottom, is if I want my expert, my performance weight expert and my equal weight experts, basically, I just want to find so that they can compare. I want to find their 5, 50, and 95th percentile. If I just hit Control F, this is why I don't do this. Control E, sorry. If I hit Control E, it will quickly go through the program, calculate the experts' 5 and 50 and 95th percentile for both the performance weight and the equal weight expert. And there they are. And now I have everything I need for the experts in terms of their calibration scores, information scores, and so forth. So that's one macro that I built in. I think if I really want to make this useful, what I ought to do is go run that for all the programs and put it in, hard coded in so people can read it in. And the other one that I have is here. And this is what I was telling you. I might want to say these 3 things and maybe a couple of these. Maybe these are the ones that I'm interested in. So I'll just put X's by the ones that I'm interested in. And then if I hit Control F, it goes through and it will populate for me a table in pretty fast. I mean, the more you put, I think the longer it'll probably take. But it'll populate that table for me. So now I can draw charts or graphs on it or whatever I want to do on it. Should be done fairly soon. There, done. So that then, like I said, the only other thing I want to add is the macro generator so that we can look at the box plots. A couple other things I want to do, but it's getting there, and having people look at it has been really helpful. Because Aka and Tina and Roger have been giving me some feedback on it and adding some things. So that's all I wanted to show everybody. Hope everybody is happy with it and would like to see it. And I'd love to see some feedback on it and some people adding, say, can you add this analysis and so forth. So done. Roger.
Yes, thank you.
Town